Hello. Today I'm going to talk to you about a project that I've got going on here at home. I'm standing at my workbench and working on some of my old computers. I never like to throw away old computers. I always like to try to fix them up so that they'll still work. I don't really use them all that much anymore, except for special tasks. But anyway, I have lots of old equipment and I try to put it together into some sort of Frankenstein machine that'll get something done for me. But one of the things I do have is a lot of these old laptop hard drives. Some of them are pretty slow. They're none of them are the solid state, the fast ones. Those are all in my laptops that I'm using right now. So this is, it's good, but it's not great. Um, but what I want to do with this one specifically is put it into one of Muskigo's old desktops because I bought one of those from the school a couple years back for pretty cheap, and I want to upgrade its hard drive. The hard drive I got from the school is pretty small, so I want to try to put a little bit larger hard drive in there, and this one will work, and it's a little bit faster. Um, but the problem is that hard drives for desktops look like this. And so you can see the difference. Obviously, there's a problem there. And so the question is, how can I get this guy to lock into a slot that is set aside for this guy right there? And so I'm going to have to design something, a case for it of some kind. And I've got a lot of raw materials around here, but to do it though, I need to be able to come up with the dimensions of it, and I need to measure those dimensions pretty accurately so I can make sure that it's snug when it gets slid into that position. I don't want, because this is one of the spinning ones, I don't want it to spin around. It's going to cause a lot of vibration if it will have a little bit of play in it. So I need it really to be snug. That's why these little threaded holes are right there. You can screw them into the slot to keep them in place so that they don't vibrate very much. It takes away from some of the stress. Anyway, so what I'm going to do here is show you my measurement of at least one or of the dimensions so you can see how I will do that. And hopefully you can use that as an example of how you would measure things here in physics. So I'm going to go ahead and slide myself over to the side if I can. And now I have this video. Sometimes it doesn't play very well with the screencast software, so bear with me here. Okay, so there it is. There's my device. You can see I have it set up so that it's right against, the ruler is right against the edge of it. And my goal is to try to figure out how long it is really, what that one dimension is. So I'm going to go ahead and stop it right there just so you can see for right now. So this is crucial. One of the things that I did is a pretty common technique. On this ruler, it's not as necessary, but on the meter sticks that you'll use in our class, it's probably one of the more necessary techniques that you want to remember. And that is to start the measurement from not the 0 line, but from the 1 line. So from the 1 centimeter line, that's where we're going to start our measurements. Why? Because particularly the meter sticks that we have in the class, they get damaged right on the ends. You may see your partners or other people's partners banging them on the floor or hitting them on things. Hopefully they're not hitting them on people. Those meter sticks are fun to play around with, but the problem is that every time you hit it against something, you damage the end of it, and you make it less precise and less accurate. And so we want to try to make sure that you have the most accurate and most precise value you can off the meter stick. The way that you do that is by starting not at the end, but at the first major mark, which is the 1 centimeter mark. Just a little note, we're not going to actually measure in centimeters, so be careful about that. So I'm going to go ahead and keep it going here. Now I just want to stop. Actually, I'm going to see if I can back this up just a minute here. Okay, now I don't know if you noticed this, but there's this thing called parallax, and parallax messes up measurements all the time. Not by a lot, but by a little bit. So look at this here. As we're looking at this at an angle, right? So I'm coming at it from an angle here. You can see that it looks like the edge of the hard drive has kind of slid over so that it's no longer on the 1 centimeter mark. But if I roll it back, to say right there, you can see, yes, it hasn't moved. It's still on the 1 centimeter mark. It's just the fact that we're looking at it from a different angle. This is why you always want to take your measurements from directly overhead. I'm going to go ahead and continue this on here. So you can see, there we go, there we go, there we go. Okay, so there it is. I think I can get a better picture of it here. I think I straightened it out just a little bit. There we go, perfect. Okay, so there it is. Now, you can see first off that it's at just about the 11 centimeter mark. What do you have to remember? You have to remember that the 11 centimeters actually means 10 centimeters because you started at the 1 centimeter mark. So now you've got just under 10 centimeters, or 0.1 meters. So I'm going to take a look at that, and what I'm going to do is try to draw on it here. So I'm going to go ahead and put my drawing tools on. Okay, so what I have here is I'm going to try to draw a line as best I can, like so. So you can see that it's actually not quite at the 11 centimeter mark, which we know really means 10 centimeter mark, because everything is off by 1, like so. So it's not quite there, so you can see it's just a hair underneath. And the question for you is then, how you have to be able to estimate how much underneath it is. And so as we look, let's see if I can get this there. As we look, it looks to me like it's right between this line and that line. Now, if this is 10 centimeters, and this must be 9.9 centimeters. Your task is not to say it's 9.9 centimeters, or just round it up to 10 centimeters because you're being lazy. Your task is actually to be as accurate and as precise as you can. Everyone who measures this will find that it's somewhere in between those two lines. And so you have to estimate how much in between those two lines it is. Well, I'm going to go ahead and guess. It looks to me like it's about halfway between those two lines. So if you wanted to, you could say this is 9 centimeters here, so 9.95 centimeters. So I'm going to go ahead and draw that out again, so you get this. So we could say that there is an estimate here of 9.95 centimeters. This one you know is true, that one you know is true, and this one is an estimate. And that's okay. That's how measurement works. You always estimate this one. Do you think everybody would agree that it's 9.9 something? Heck yes, they would. So there you go. So 9.95 centimeters. Now, the one problem with that, of course, is that we can't use centimeters. So to be able to change into meters, I have to go ahead and move the decimal point over by 2 places. So it ends up being this, is my answer. So that's how long it is. I could then do exactly the same thing to measure its width and its depth, and then be able to figure out how to build the case from there. Hopefully that helps. Good luck.